All right, so today we're going to be covering triangles. Okay, so there are two different ways to classify triangles. We can classify them by their angle measures and by their side lengths. Okay, so classifications of triangles by their angles is you have acute triangle. So acute is when all their angles are less than 90 degrees. Okay, so a triangle that has 3 acute angles. Okay, an equal angular triangle. So an equal angular, now if you notice equal has like the word equal, so equal angles, that's what it means. Okay, so that means that all the angles are the same. This is called equal angular. And then we have a right triangle. So it's a triangle that has one right angle. Okay, and then the next one we have an obtuse triangle. So in order for it to be an obtuse triangle, it has to have one obtuse angle. Okay, so all it needs is just one. So here it says classify the triangles by the angle measures. So if we look here, 36, 54, and then this is a 90-degree angle. So this is considered a right triangle, right? And then the symbol for triangle is a triangle. Okay, then we look at this next one. We look at the angles. We have 103. 103 is an obtuse angle, so that makes this an obtuse triangle. Okay, then the next one here, we have 61, 70, and 49. All of these are acute triangles, so 61, 49, and 70. That makes this one acute triangle. Okay. The next one, number 4. So this one has 3 different triangles. So the first one that they want us to look at is DFG. So DFG is this big triangle here, DFG. Okay. And then if we look, this angle is 54, this one's 36, and then this one right here is the right angle. It's the whole thing, not the 32, because that's just that little piece. So that means this one is a right triangle. Okay, the next one here, it's a triangle DEG. So DEG. Okay, so this one is 54. This one is 68, and then this one, we don't know what it is, but we do know it's less than 90 because it's cut. That 90-degree angle is cut. So that makes this an acute triangle. I forgot to put the symbol for triangle here. Okay, and then the last one, let me get out a different color. What color don't I have? Let's just do this one. Okay, so EFG. So EFG is this triangle right here, E to F to G. Okay, so if we notice, this one's 32, this one's 36. So this angle right here, if you notice, it's supplementary to this one, the 68. So if we do 180 minus 68, that gives us 112. So 112. And so that is an obtuse angle. So that one is an obtuse triangle. Okay, the next one is classification of triangles by sides. Okay, so we have 3 ways that we can classify it by sides. The first one is equilateral. So if you notice, equi means equal. That means that it has 3 congruent sides, or the same thing as congruent is equal. Then you have your isosceles triangle. Now, isosceles is when you have 2 congruent sides. So the way I remember that is you have 2 eyes, isosceles. Okay, so 2 sides are congruent. And then the last one, you have your scaling triangle. That means that it has no congruent sides. So none of the sides are going to be the same. They're all going to be different numbers. Okay, so once again, we do have several triangles. We have triangle DFG. So D to F to G. So they're talking about this big triangle here. If you notice right here, they have the 2 little tally marks. That's telling you that those 2 sides are the same. So it has 2 congruent sides. That's going to make this isosceles triangle. Okay, then we have triangle DEF. So D to E to F. So this one has 1 tally mark and this one has 2 tally marks. That doesn't mean that they're the same. That means that they're different. That's why they use 1 here and it uses 2 here. And then this one says 14. So they're all different. That makes this a scaling. triangle. And then triangle EFG. So here we have E to F to G. So we have these three here. We do have one tally mark here and one tally mark here. So that means that this is going to be an isosceles. I'm not spelling this right, sorry. Isosceles triangle. Okay, let's go ahead and look at the next one. So they want us to classify the following triangles by side lengths and angle measures. Okay, so we're going to do both side lengths and angle measures. So first we're going to go ahead and look at this one. We look at the side lengths, 4, 3, and 5.4. They're all different, so that's a scalene. And then we look at the angles. It has one obtuse angle. It is 100, so this is a scalene obtuse triangle. Okay, the next one. Okay, it gives us little tally marks to show us that all the sides are the same and all the angles are the same. Okay, so this is an equilateral and equiangular. There you go. And then the next one on here, they tell us that two of the sides are congruent. So this is going to be isosceles. And then this one is right. So isosceles right triangle, because it does have that one right angle. Okay, so that's how we label them by names. Now next we're going to go over some relationships based off of the angles. So we have the triangle sum theorem. Okay, this says that the three angles in this triangle should add up to 180. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Okay. Then you have your right triangles. So here we look at our special cases for our right triangle. We know that one of the angles in our right triangle is always 90. Well, if the three angles of a triangle should add up to 180 and one of them is already 90, when we do 180 minus 90, that gives us 90. So what that's saying is that the other two angles should always add up to 90, okay? All right, the next one is the exterior angle theorem. So this one's saying that angles, we have exterior angle, which is angle 4 right here. And so angle 4 should be the same thing as adding angle 1 and angle 2 to it. So the measure of angle 1 plus the measure of angle 2. All right. Next is the equal angular triangle. So when all the angles are equal, and we know that the three angles of the triangle should add up to 180, we divide it into three equal parts, and that gives us 60. So when it's an equal angular, it is going to be, every angle is going to be 60. Okay, so that's how they get this one. And then the third angle theorem, if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent. So pretty much what this is saying is, for example, they tell you 1 is the same as 4 and 2 is the same as 5. Then you don't even have to find what the measures of 3 and 6 are. You can automatically assume that they are equal as well. Okay. All right, so if we look at this first one, it says find the measure of each angle. Well, we know that the three angles should add up to 180. So the measure of angle A plus the measure of angle B plus the measure of angle C should all equal 180. Well, we know that the measure of angle A is 30. We don't know what the measure of angle B is. Plus the measure of angle C we know is 35. So all I did was substitute this, and this should equal 180. Okay. I'm going to combine my like terms. 30 plus 35 gives me 65 degrees plus the measure of angle B equals 180. Okay. Then to solve for B, or the measure of angle B, we go ahead and subtract the 65 on both sides. 180 minus 65 is going to give me 115. Okay. Now looking at the next one here, they want us to find all of these angles. So first I'm going to see what they give us. Okay. They give us this angle is 49 and then this one is 84. So if we notice this small triangle right here, we can find this angle by subtracting these two from 180. So I'm not going to show you all this work all over again. We're just going to do 49 plus 84. So those two angles together give us 123. Okay. So all three of them need to add up to 180. So we're going to do 180 minus the 123. And that gives us 57. Okay, so 57 degrees is this one, 57 degrees, which is ABC, this one right here. Okay, now we are going to look at the bigger triangle. So we're going to look at the whole thing here. Okay, I know this one's 46. I know this one's 57. So I'm going to do 46 plus 57. And whatever I get from here, I subtract it from 180 because the three angles should add up to 180. So 46, let's see, 6 plus 7 is 13, 103. Okay, and then we're going to go ahead and do 180 minus 103. And that gives us 77. Okay, that means this whole angle right here is 77. And we already know that this section is 49. So I'm going to do 49 minus 77. Oh, the other way, 77 minus 49. This is going to give you 17, 6, 26. No, 20, 28, sorry. Yeah. So that means this little section here is 28 degrees. Okay. And then the only little angle that we're missing is this one right here. Okay, so I'm going to go ahead and erase this. I'm going to keep that whole thing at 77. That section is 28. And now we're going to look at this triangle right here. Okay, so we know that this angle is 28 and this one's 46. So to find this one, I'm going to do 28 plus 46. That gives me 74. And then we're going to go ahead and take 180 and subtract the 74. And that gives us 106. Okay, so that is going to be DCA, which is 106. And then the other one is DAC, which we found to be 28 degrees. Okay, number 11. So number 11, we have this right triangle. So remember the rule with our right triangles is right here. It says that if one of the angles is 90, then the other two angles need to add up to 90. Okay, so if we look here, these two angles need to add up to 90, the angle E and angle F. So I'm going to do 90 minus 20. That's going to give me what F has to equal, and it has to equal 70. Okay. If you wanted to double check, remember the three angles of the triangle need to add up to 180. So you do 70 plus 20 plus the 90 degree angle. Okay, and that does give you 180. All right. We have number 12. We have another right triangle. So here, this one is 41 degrees. And this one has to add up to 90 with it. So we do 90 minus 41. And that gives us 49. Okay. All right. The next one is going to be our exterior angle theorem. So this is my exterior angle. Okay. The exterior angle should add up to the two opposite angles. The two opposite angles are L and K because J's right here, that's not the opposite. So we're going to do 30 is equal to whatever the measure of angle L is plus the measure of angle K. Now 130 is equal to, we don't know what the measure of angle L is, but we know that the measure of angle K is 65. So when we subtract the 65, 130 minus 65 is going to give us 65. So this would be 65. Okay, so here we have the same thing. We have this exterior angle, which is the measure of angle 3. We don't know what it is. Okay, In the last problem, they gave it to us, and this one, they didn't give it to us. And then we add the two opposite angles. So 75 plus 38. So the measure of angle 3 equals, when we add 75 plus 38, let me see, 5 plus 8 is 13. We carry the 1, so it'll be 113. Okay. We have another exterior angle theorem. So here we have the measure of angle 6 again. That's the exterior angle because it's outside the triangle. It's going to equal to the two opposite angles. Okay, so not this angle that's touching it, but the two opposite ones. So we go ahead and add them together. 68 plus 28. That gives us 80, 96. All right, this next one, they tell us that all of the angles are the same. G, H, and I are all equal. So remember, if they're all equal, we know that 3 angles of a triangle should add up to 180. We divide that by 3, and that gives me 60. Okay, next here, this is the third angle theorem. So they give us angle R is the same as U. We don't know what it is, but we know they're equal. We know Q is the same as T. We don't know the number, but we know they're equal. So that means that the third angles should be equal. So that means X should equal 35 degrees. All right, the next one we have number 18, we have the measure of angle 1, 2, 3, and 4. So we need to find all of them. So if we notice here, this is a 90-degree angle. So that means the other two angles need to add up to 90. So to find measure of angle 1, we're going to do 90 minus the 38, which gives us 52. Yeah, 52. So measure of angle 1 is 52. Angle 4. Angle 4 is an exterior angle. So to find the measure of angle 4, we have to add the two opposite angles. So if you see here how 1 is touching angle 4, that's not the numbers that you add the opposite one. So the opposite one would be the 90-degree angle and the 38. So the measure of angle 4 is equal to 90 plus 38, which gives us 128. 128 degrees. All right, the next one. Okay, here we have angle 2. So to find the measure of angle 2, we have to add the two opposite angles. So the 38 is here with the 2, so that's not the opposite. The 90 is going to be the opposite, and the 52. So to find the measure of angle 2, we do 90 plus 52. And that gives us 142. Okay, and last is the angle 3. So angle 3 is on this outside right here. This is angle 3. We don't know what it is. Now this 90-degree angle is side by side with the angle 3. So then you need to add the two opposite ones, which would be 38 and 52. So to find the measure of angle 3, we're going to have to add 38 plus 52, which gives us 90. Okay. Now, that's not the only way you guys can find the angles. I know there's other ways, but I'm just using the theorems for today. Okay, so this one wants us to find all of these angles. This time they're not numbered, so I'm just going to go ahead and run through them to find them. Okay, so starting off with what they give us. They give us this exterior angle, which is 118. And so this angle should be equal to the opposite angles equal. So the 47 and whatever that one is. So 118 degrees should equal 47 degrees plus the measure of that angle right there, which is going to be BCD. Okay, they didn't put a little number there for us, so we have to use all three letters to name the angle. So to figure out what that is, we go ahead and subtract the 47. I don't know what I wrote. Minus 47, minus 47. This cancels. Let me go ahead and do 118 minus 47. That gives us 71 equals the measure of angle BCD. Okay, so this one's going to be 71. Okay, so then to find this other angle here, well, we already know two angles of the triangle. We know one's 47 plus 71. That's that's going to give us, this is 8, 118. We go ahead and subtract that from 180. So 180 minus 118 gives us 62. So that means this angle right here, I'm going to put an arrow, is 62 degrees. Okay, so we have some exterior angles that we need to find as well. So we have this one out here. Now it's touching the 71. So then the opposite angles are the 47 and the 62. So 47 plus 62 gives us 109. Okay, and then here I have this outside one right here as well. The 47 is touching it, so I need to add the two opposite ones, which are the 71 and the 62. And that is going to give us, this is 3, this is 13, yeah, 133. 133. Okay, so let me go ahead and figure out what they are. We have A, B, D is a 133. Then we have B to D to C. That's the one that we found. BDC is this one. That's the one that we found to be 62. And then we have BCD is 71. BCD is this one right here, 71. And then BCE is the exterior angle, which is 109. Okay, so it does get a little bit messy, but all this is just adding and subtracting, okay? Isosceles triangles, so if two sides of a triangle are congruent, then the angles opposite the sides are also congruent. So for example here, if they tell you these two sides are the same, then these two base angles are the same, okay? The same goes the opposite way. If they tell you these two angles are the same, then you should automatically assume that those two sides are the same. So we have our equilateral triangle. Whenever all the angles are equal, I think we went over this already, all the sides are also going to be equal. Okay, so here it says find the measure of each angle. So if this angle is 78 and then they tell us these two sides are the same, then that means that these two angles are going to be congruent. Okay, so the way that we find them is we do 180 minus the 78, and that gives us 102. Okay, so that means these two angles need to add up to 102. So we go ahead and divide that by 2 since they're equal, and that's going to give us 51 each angle. Okay. If you wanted to go ahead and double check to see what it gives you, you just do 51 plus 51 plus 78, and you make sure that it gives you 180. Okay, this next one, the same concept we have in an isosceles triangle. Okay, those are two congruent angles, so then these base angles are congruent. Okay, those sides opposite. Okay, so then from there, we're going to do the same thing like we did on the last problem. We do 180 minus 86, and that gives us 94. We go ahead and divide that by 2, 45, 46, 47. So both of those angles are 47 each. Okay, this one adds a little bit more. So they do tell us that these two sides are congruent. So this 51, that means this one also has to be 51. Okay. So let's go ahead and find that angle here on the top, this whole angle right here. So we're going to do 180 minus 51 minus 51. So that is going to give us 102. Okay, so this whole angle here is 102 degrees. And if you notice, they have little arc marks right here. So that means that they're equal. So each little piece, if we do 102 divided by 2, that means that each one of these is 51 as well. Okay, so we know x is 51 so far. Now we need to find y. So to find y, we're looking at just this triangle right here. So if this is 51 and this is 51, to find this angle, we're going to do 180 minus 51 minus 51, which we already did here, gives us 102. That's it. Okay, the next one, I believe this is the last one, yeah. Okay, so it tells you to find all of these angles. So I'm just going to look here first at my diagram to see what they give us. So they give us, this is 50, and I'm going to find as many angles as I possibly can. They also tell us that these two sides are the same. So I'm going to do 180 minus the 50. That gives me 130. I divide that by 2 because if the two sides are the same, that means that these two angles should be equal. So 130 divided by 2 is going to give me 65. So that means each one of these is 65. Okay. And then from there, we can find this angle right here. Okay, this is the exterior angle. So to find that exterior angle, you add the two opposite angles, which is 65 and 50. Okay, so 65 plus 50, that gives me 5, it gives me 150. So that means this angle out here is 150. Okay, the next thing that I do notice is that these tally marks here mean that all the sides are the same, so that means all the angles have to be the same. Well, if all the angles are the same, 180 divided by 3 would give us 60. So all the angles would be equal to 60. Okay. Now this rule, you can remember, these are considered vertical angles, right? So these two, since they're across each other, this is 60 degrees. And then we have this exterior angle right here. Okay. Now this exterior angle is going to be equal to the sum of the opposite angles. So those two angles here. So 60 plus 60 gives us 120. Okay, and that means that this one would also be 120 because they're vertical angles. Okay, next, and I think it's the last angle, is this little piece right here. Okay, this one you have to remember from a previous lesson. We should know that these three angles together, the 60 plus whatever this section plus this one, should add up to 180 because they make a straight line. They make a straight angle. So 180, we subtract the 60 and the 65, and that gives us 55. So I'm going to go ahead and answer my questions. The first one's asking me for B, C, A. So B, C, A is talking about this one. It is 60 degrees. The next one is asking for D, E, F. So D, E, F is talking about this exterior angle, which is 115 degrees. The next one is B, A, G. So BAG is going to be 120 degrees. We have DCE. DCE is talking about this angle here, which is 65. Then we have BCD. That one is 55 degrees as well. And then we have GAH. GAH is this one. This one is 60 degrees. And that's it. Thank you guys. We'll see you next time. Bye.